Okay, in case of fluid flow to a long, smooth bore horizontal circular pipe, we are interested in the pressure drop per unit length, delta PE. Okay, the first step for the dimensional analysis, we list the variables that are involved in the problems. So we have 5 variables. Okay, it's a delta P, delta PE, D, rho, mu, and velocity. Okay. The next second step, express of each of the variable in terms of the basic dimension MLT or FLT. Okay, that we list this for the files. For the first law is the FLT and the second law is MLT. Okay, but sometimes if you don't, for example, for FLT for row, okay, if you can't remember the basic unit of FLT, we can derive from what we understanding. For example, density is equal to mass times volume. Okay, and in this case, its mass is equal to FMA. Okay, from the second law of the Newton, and in this case is rho. We substitute the mass in this equation, so we go to F divided by a volume, and in this case F is equal to, for acceleration, is equal to L length times T minus 2, and for the volume is equal to length power 3. So finally we got F, the basic unit for the density is equal to F times L power minus 3, not 4, and T minus 3 power 2. Okay, so it's similar to what we got here. Okay, you can derive by yourself for if you don't can't remember the basic unit of the density. Okay. The third step is determine the required number for pi term. So in this case, we choose basic unit is equal to 3. So number of pi term is the 5 subtract 3 is 2. Okay. Step 4, select a number of repeating variable equal to number of the basic. From this, so we select the D, V, and rho as a repeating variable. Okay, and is dimensionally independent, cannot form dimensionless product from this list. Okay, and the step 5, we form 2 pi term. Okay, the first pi term that is non-repeating variable delta PE, and this D, V, and rho is a repeating variable, and power ABC. Okay, and the next we form substitute the basic unit in this term, and resulting exponent of each FLT must be 0. Okay, so we can say that for the F, the power of F is 1 plus C equal to 0, and power of L is this minus 3 plus A plus B, and subtract 4 is equal to 0, and T, okay, B minus B plus 2C. So in this case, we can solve for this constant. So in this case, C is equal to minus 1, and in this case, we substitute C minus 1, we got B is equal to minus 2, and we substitute in above. So 3 unknown is A, and plus B, or B is minus 2, and plus 4 C, so it is equal to 0. So we can prove that we can solve the equation to get come up with the A is equal to 1, So A is the power of the D, okay, and B is negative 2. B is the power of the V, okay, and C is equal to -1. C is the power of rho. So we got this first pi term. We can prove later that this term is the dimensionless parameter. The next step is repeating the remaining non-repeating variable. So another non-repeating is mu. So we do the same. Okay, and we substitute the basic unit in all variable and find equation for f, the power of f lt equal to 0. So we can solve to find what is, in this case is c is equal to subtract 1, and because c subtracts to the third equation 1 plus subtract b and subtract 2. Okay, so we can know that b is -1. B is equal to -1. And next we substitute in the second equation for 2, and B is -1, and C is plus 4. Okay, so we come up with we come up with the solution that A is equal to -1, and B is -1, and C is -1. Okay, so we come up with the second pi term. Okay, and the next step 7, we checking then make sure that all the results pi term are dimensionless. So we just substitute the basic unit for the first pi term and second pi term to prove that is the power 0. Or we can substitute in terms of the MLT to prove that is all 0. Okay. And second step is express the result of the matrix analysis. So we can write the first pi term is a function of the second pi term. Okay. And can rearrange the this equation for this for the Reynolds number Vd over mu. Okay, in this case this look like the V, but it's just the nu. Nu is the kinematic. Kinematic viscosity, the unit is the m square meter square per second. Okay, and from this we can run experiment to get the relationship between these two parameters. Okay, to run the experiment to get the relationship between these two parameters.